Okay, so it came to my attention that some of the videos that I put up for the in-class assessment kind of cut short. In fact, quite a lot of them for the 30-minute assessment. So I thought I'd just go through and sort of show you the answers at least, so you can pause it and check through at your own pace. This one, the only thing I'll quickly say is just make sure that you actually include your reasons. It says give a reason for each stage. If you don't, you're only ever going to get 2 marks out of 4. But yeah, you can pause that and have a look through. Question 6 on this one, the key bit was to realise that if this is a rectangle, 2x plus 6 and 5x minus 9 must be the same. They must be equal, which allows you to go through and solve for x. And from there you can work out the length of a side and work backwards to find y. So again, I'll leave the work in there, you can pause it. Question 10, anything to the power of a half is the square root. Something to the power of 2 over 3. The 3 on the bottom means you cube root it. The cube root of 125 is 5. And the 2 on the top of the power means we then square it, which gives us 25. 11, simultaneous equations. So 3t plus 2c equals £7.80. And 5t plus 4c gives you £14.20. And then I've made the c's match up so that I can subtract through, and then I'll let you pause it and look at the rest of the question. Question 14. If these are equivalent, think about what you have to do to the right hand side to get to the left hand side. 1 times k gives me k. So if this is equivalent, y minus x times by k must give me y plus x, which is basically what I've written here. Y minus x times by k gives me y plus x. Now whichever way you do this, if you want to make y the subject, you've got to then, when you're rearranging it, get all the y values on one side so that you can factorise to get y by itself. And this left hand side working, it's the exact same thing as your final answer. It just looks different, your signs are the other way around. So up here I've done it where we take the y's to the right hand side, we factorised to get a single y, and then rearranged it to get what we're after down here. So I'll let you pause it, have a look. Question 15, we've done a lot of stuff on like recurring decimals into fractions, so I'll just leave that there for you to pause and have a look through. And then lastly, question 23. It talks about the area of the rectangle, which is x minus 1 times 3x minus 2, which I've got here. The area of the triangle it mentions, so we'll just work that out. Don't forget to divide it by 2 because it's the area of a triangle, so you get x squared. So the area of the rectangle, which is this, is greater than the area of the triangle. That's what the question tells you. And then if I subtract x squared from both sides, this becomes 2x squared, that becomes 0. Once you've got a quadratic that where one side is 0, you can then go ahead and solve it. Now down here I've solved it using the AC and B method as if it's an equation. But remember, for a quadratic inequality, once you've got your two values, you need a sketch. That's not your answer. That would be the answer if it was equal 0 here. But these two values you can then put on the sketch, draw it in, and we want the bits that are greater than 0. So this bit and this bit, which is why it's less than a half or greater than 2.